Yeah, good morning, guys. Today I'm going to look at distribution function, and so let's look at the definition. Let x be a random variable. This here RV means a random variable. The function f of x, which is a real number, maps to 0 and 1. So what this means here is that with the distribution function that we're going to have, the minimum number that it can take is 0, and the maximum number it can take is 1. So always your distribution number is 0, between 0 and 1, 0 with 0 and 1 inclusive. Yeah. With f of x equals to probability that x is less than or equals to t is called distribution function. So let's say we have this example that a fair die is thrown once. Now, when a fair die is thrown once, we're just going to assume that it's a uniform distribution. That means they all have equal probability of us showing up. So calculate and draw the distribution. So let's say you throw your die. So what is going to be the sample space? That the omega, let me see, omega is equals to 1, 2, 3, 4, 5, 6. So that means when you throw your die, this is the possible likely outcomes: 1, 2, 3, 4, 5, 6. Now the f of x with the distribution function, we know f of x of t, right? Where we said is equal to what? Probably that x is less than or equals to t. Is okay. So this is what we are going to look at. So first of all, we start with f of x. So what is when you throw the die? Is okay. So what is the likelihood that you have the outcome lesser than 1? Is it possible to throw a die and have an outcome like 0? Anything less than 1? This is impossible, right? So that part is 0. So we say 0 for t less than what? 1. So what if you throw the die? What is the likelihood that you have what for t less than or equal to 1? So we have then 4. The next one becomes 4. 1 less than or equals to t and less than 2. Or it can also be written at when t belongs to 1 with 2 not inclusive. So this expression here means 2 is not part, but this expression here means what? And 1 is included. So that means when you throw the die, so you have either 1, right? With 2 not inclusive is going to be only 1, right? And the probability of having 1 is what? 1 over 6. It's equal to 1 over 6. It's equals to 1 over 6 for 1 less than or equals to t and then less than 2, right? So the next one is, what is the likelihood you have something less than or equals to 2? So it's going to be for, this one is going to be for t belonging to 2 but 3 not inclusive. Is okay. So, or the same as 2 is less than or equals to t and t is less than 3, right? So that means it's either you have 1 or 2, right? And the probability of having 1 is what? 1 over 6. And that of all 2 is also 1 over 6. So 1 over 6 plus 1 over 6 becomes what? 2 over 6. Is okay. That is going to give you 2 over 6. Is okay. Now the next one is for t belonging to t belongs to 3 and then 4 not inclusive. That means probability of x is less than or equals to what? 3. Now x is less than or equals to 3, so the probability of 1 plus probability of having 1 plus the probability of having 2 plus the probability of having 3, right? Because 4 is not inclusive. That is also going to give what? 3 over 6. It's 1 over 6 plus 1 over 6 plus 1 over 6. That is going to give you 3 over 6. Is okay. Now the next one becomes for t belonging to 4 with 5 not inclusive or not included. Is okay. So that is also going to give you probably that x is less than or equals to 4. That is that probability of having 1 plus probability of having 2 plus probability of having 3 plus probability of having 4. It's okay. That is also going to give you 4 over 6. Then you go to the next one, for t belonging to 5 and then not 6, with 6 not inclusive. It's also going to give you, when you add up, it's probably that x is less than or equal to 5. That will give you probably of 1 plus 2 plus 3 plus 4 plus 5. That gives you 5 over 6, right? And the next one becomes 4. T belonging to 6 with infinity not inclusive. Up to infinity, right? Whether the x is greater than 6. That's what it means. So that is also going to give you plus 1, probability of 1, probability of 2, probability of 3, up to 6. That is, when you add that is going to give you 1, right? So this is what we call the distribution function. It's okay. So this is what we call the distribution function. So the next one is if you are asked to draw the distribution. So if you are asked to draw the distribution, the probability is going to be on the vertical, and the horizontal becomes x. So we have 1, 2, 3, 4, 5, and 6, right? So first we said probability of having anything less than 1 is what? 0, right? So that 0 is going to be this part. It's okay. Now then the next one becomes probability of having one with two not inclusive. We had 1 over 6. So let's say this expression is 1 over 6 here, right? So 1 start from here with 2 not inclusive, it ends here, right? So that's going to be 1 over 6. And the next one start from 2 with 3 not inclusive, right? That is also going to give you 2 over 6. Right, so 2 start from here with 3 not inclusive. It's going to give you something like this. The next one is 3 with 4 not inclusive, also gives you 3 over 6. Right, so that also starts here and ends here. And the next one is what? 4 with 5 not inclusive, that also gives you 4 over 6. It's okay. That also starts from here. And the next one is 5 over 6, right? That is also start from here and ends here. And the next one is 6 and up to infinity was 1, right? So the last end here, which is 1, is 6. So start from here and up to infinity is also 1. It's okay. So this is what we call the distribution. Draw the distribution. Is okay. Great. This is the first example, and in my next video, I'm going to look at another example. Thank you.